All right, ladies and gentlemen, we've reached the end of 8.4, and as a matter of fact, we've reached the end of chapter 8. We're talking about choosing and creating a data display. You've been shown box and whisker this year. There's scatter plots, there's bar graphs, there's histograms, there's circle charts, and then you can double a lot of these things. You can do a stem and leaf. So there's lots of ways to be able to represent data. I'm going to tell you this. A lot of times in the real world, it's going to come down to how does your boss like seeing the data so they can read it quickly, efficiently, feel comfortable with it. So you're just going to have to learn how they like to see it. But sometimes it's just what's the best visual representation. My experience comes down to bar graphs, histograms, and circle graphs in most cases. When it comes to science and studies and looking at variations and things like that, you add in box and whisker plots. Scatter plots are good, but they kind of just show a representation of the data, not an easier way to interpret the data, I guess is the way to look at it. It really just comes down to that question. How am I going to help somebody else interpret the data? Not give them an interpretation, not give them an answer, but help them interpret the data quicker, easier, where they are more comfortable with it. That's the actual way to choose. I wouldn't say when you have this type of data, you must use this chart. No. It's a little bit more fluid than that. So two examples we have are eye color and speed of vehicles. We could represent the speed of vehicles with a circle graph, with a bar graph, and do different things like that. But it actually shows pretty nicely through through interpretation and be able to sit there and say, oh, well, Interstate B, the median speed or the average speed, the median speed is actually higher than Interstate A. What is there posted? Does that mean more people speed on it? Why are they speeding on it? Are there more straightaways than curves? Is it a busier highway? Is that why Interstate A is slower? Things like that, but that gives me that snapshot of, oh, they travel faster on Interstate B. For 50% of everybody travels faster, it looks like. Or at least the speeds are 50%. Are within that 50% range, things like that. And so B actually allows me to interpret that data almost instantly when I look at it and go, oh, people travel faster on B than A. And if that's the purpose of the study, this would be a great and perfect example of how to represent that data. And eye color. Eye color is somewhat random, but it's due to genetics. It looks random on our end. But if you follow genetics all the way back, you can actually start predicting what kind of eye color even your kids will have, or at least the chance that they'll have. And so a pie chart actually helps represent that nicely. It shows, like blue is almost 25%. Hazel's a little under 25%, but hazel and green make up about 25%. Brown's pretty close to 50% of the population. So it's a quick snapshot. Snot? Ugh, I wouldn't want that either. It's a quick snapshot. And what's the best snapshot you could take to help somebody else interpret? That is really how you're going to choose and create a data display. And in part, it comes down to how does my boss like seeing this data so they can quickly look at it, read it, interpret it, and go.